Hello everyone, now we are going to study our new topic, that is kinematics of particles. In the previous chapters we have studied about the statics, now we are going to study about the dynamics part. So in kinematics, actually we are going to study the motion of the bodies without considering their forces, the forces which are responsible for the motion of the bodies or the particles. In statics parts, we have only studied the analysis of forces when the bodies or the particles are in the static condition or at the rest condition. But now in this chapter, we are going to study the particles or the bodies when they are in motion, but not considering the cause of the motion. So basically this kinematics is a part of dynamics. Dynamics have actually two parts, that is, one is kinematics and another is kinetics. In kinetics we are going to consider the force system also, which is responsible for the motion of the body. But here in this chapter kinematics we are not going to consider any kind of force, means you will not get any kg means mass, weight which is to be measured in Newton, nothing you will get in this chapter. But apart from forces, velocity, acceleration, these terms you will find in this chapter. So starting from the definitions in this chapter, those definitions involved in this chapter, first of all we should clear about the rectilinear translation or rectilinear motion, what does it mean. Next thing is curvilinear translation, next is centroidal rotation and rectilinear translation and rotation. These terms should be clear to us. So defining this term, first one is the rectilinear translation. Rectilinear translation or rectilinear motion, you can also say it as a motion, rectilinear translation. So what does it mean? It means that the motion of a body in a straight direction, in a straight line. Why does it occurs? Why does it happens only in a straight, why does it moves only in a straight line? Because when the resultant force of a given force system is applied at the CG of the body, means at the center of gravity of a body, then body will move in the direction of resultant only, okay, without any rotation. So this type of motion is called as a rectilinear motion because this motion takes place in a straight path. Okay, so first of all we should know the meaning of rectilinear motion, means the resultant is applied at the center of gravity, then the motion will take along the direction of resultant only. So in this way this motion becomes a straight line motion. Next term is curvilinear motion. Curvilinear motion, or you can also say it as a translation, curvilinear translation. Now what does it mean? Actually the resultant acting on a body, resultant force which is acting on a body is not at the CG, so it will cause a motion along the curve path. So this motion along a curve path is called as curvilinear motion. Suppose this is a body and this is the CG of the body. If this force is applying here, then it will take place in a straight line direction, and this motion is called as rectilinear motion. And what about curvilinear motion? This force, suppose it is applied here, this force is applied here, then this will not take in the direction of the resultant. Actually what will happen, if it is applied here, the motion will not be in a straight line direction, it will something like this, okay, it will move in this direction. So the direction of resultant and the direction of a movement of the body or a motion of a body is not in the same line. This type of motion is called as curvilinear motion. Next type of the motion is a centroidal rotation. Centroidal rotation. In the above two cases I have said that the resultant force is acting over the CG. Now in centroidal rotation it is not a resultant force, but it is a resultant moment which is acting at the CG, about the CG actually, due to when the resultant moment acts about the CG, body will rotate by its axis only itself, okay. So this type of motion which is along the CG axis, centroidal axis of the body, is called as centroidal rotation. Okay. And the fourth and the last type of motion we have to study in kinematics of particle is the combined motion. What is there in combined motion? It is rotating as well as translating. Combined motion. What is happening in combined motion? Body is rotating as well as translating, means there is a translation as well as rotation. So this when this combination is there, then it is called as combined motion. Means to occur this combination, what is required? A single force and a couple is required. If these two things are there, then combined motion will take place. For rotational motion, couple is sufficient for its motion. For curvilinear motion, a force is required, but it should not be act over the CG of the body, then curvilinear motion will occur. For rectilinear translation, the force or a resultant should be applied at the CG of the body, then this type of motion is possible. So we have studied these four types of motion. Now in this chapter we shall analyze the rectilinear motion of a particle under uniform and variable acceleration using equations of motion and motion curve. Okay, and later on we shall then analyze the motion of particle under gravity. These two things we have to study in this chapter, kinematics of particles. Now coming to the part of basic terms and definition. So the first one is the motion. What is the meaning of motion? Actually we should know this, or we should be able to define this term, that is motion. Actually it is the change in position of a body with respect to a specific point. Change in position. What is the meaning of motion? Motion is a change in position with respect to a reference point or a specific point, anything we can say, a reference point. It is called as a motion. Means when a body or a particle changes its position, means it have taken a motion. Okay, now the next simple term is a path. Now what is the meaning of path? Means when a body moves in a space, okay, it describes a curve or a straight line, then it is called a path. Body moves in a space, okay. If it moves in a space, it describes a curve or a straight line, that is called as a path. Okay, next term is a distance. Now what is the meaning of distance? Actually it is the length measured along the path of the body. Length measured along the path of a body. Length measured along the path of a body. To understand the meaning of distance, let us consider this example. Suppose this is the first point, the name of the point is A, and this is the last point, suppose the name of the point this is B. And to move from this point to this point, a particle describes this path. Suppose it describes like this a path. Suppose this is the path of the particle to reach from A to B. Then this path which is traced by the particle, this path is called as actually the distance. Okay, means here direction is not important. Direction may be from this side or it may be from this side. The important thing is the length or this distance actually, which is important in this case. Means distance is what actually, it is a length measured along the path of the body. Means we have to measure the length along this path, then you will get the distance. Now so here the direction is not important, means it is a scalar quantity. Okay, so next the term which is to be noted is, it is a scalar quantity. So you can say that it is a path or a length measured along the path of the body, and the path is, suppose it is here B I have written, so it's C, D, E, F and G suppose. So the distance in this case, in our case, the distance is A, C, D, E, F, G and B. This is the distance which we have covered from A to B. Now the next term is the displacement. Now what is the displacement? It is change of position of a particle in a definite direction, and it is measured by the straight distance between the initial and final position of the particle. Means this is the point A and B, and there is a change of the position. The particle is changing its position from point A to the point B. Okay, now it is changing the position from A to B in a specific direction. Suppose this is the direction. In this direction the particle is changing its position. Now here I am saying the direction word also, means it is a vector quantity. So displacement is a vector quantity. Okay, so it is the length which is measured between the two positions with a specific direction. Okay, so we can note this that this is a vector quantity. Now the next term is speed. Now speed is defined as a rate of change of distance with respect to time. Rate of change of distance means if we denote speed by suppose any term, suppose small s, we are denoting it by small s, suppose this is small s, then it is defined as a rate of change of distance. Now distance is denoted by capital S, so rate of change of distance with respect to time. This is the definition for speed, or we can also call it speed as a rate at which particle describes a path. Okay, so the speed is a scalar quantity because it depends upon the distance. This is s, means it is a distance, and distance is a scalar quantity. So speed is also a scalar quantity since it takes into account only length of the path and not its direction of motion. Okay, so unit of the speed may be a meter per second. Unit may be meter per second. Unit of displacement may be meter, and unit of distance may be meter only. Okay, so in this way we have defined the speed also. What we have to remember, that speed is a scalar quantity. Second term is velocity. Another term is velocity after speed. Another term is velocity. It is defined as a rate of change of displacement. Okay, so it is a rate of change of, suppose velocity we denoted by v, then it is rate of change of displacement. Okay, I have defined already what is the meaning of displacement, rate of change of displacement with respect to time. Here we have to consider displacement. It means that velocity is a vector quantity. Okay, it is a vector quantity. The unit of the velocity will be same, that is meter per second. So in this way velocity is also defined. Next term is uniform velocity. What is the meaning of uniform velocity? When a body undergoes equal displacement in equal intervals of time, then it is called as uniform velocity. And what is the meaning of variable velocity then? When a body undergoes unequal displacement in equal intervals of time. Means there is a equal interval of time, but the distance or the displacement covered will be, if it is equal, then it will be called as a uniform velocity. But in a particular interval of a time, if displacement cover is not equal, means it is a variable velocity. So these two terms are very important in this chapter, that is uniform velocity and variable velocity. Means what is happening here? Equal distances, equal displacements in equal interval of time, in equal interval of time, then it is called as uniform velocity. But unequal displacements takes place in equal time only, in equal interval only, in equal interval of time, then this type of motion is called as having a variable velocity motion. Okay, so these are the two terms which are important, uniform velocity and variable velocity. Now one thing common is that equal interval of time, and the different thing is that equal displacements, here unequal displacements will take place. So this is the difference between uniform velocity and variable velocity. Now what is the meaning of acceleration? The term acceleration, it is the rate of change of velocity with respect to time. Rate of change of velocity with respect to time, it is called as acceleration. When when a velocity of a body is increasing, suppose the velocity of body is increasing, the acceleration is positive. Means if velocity is increasing, then we can take acceleration as a positive, but if it is decreasing, then we can take acceleration as a negative quantity. Okay, now saying about uniform acceleration, what is the meaning of uniform acceleration? Actually, when a velocity of a body changes by equal amount in equal intervals of time, then it is called as a body having a uniform acceleration. Means what here we have said, here we have said that equal displacements in equal interval of times. Now we are saying that body, when a velocity of a body changes by equal amount, velocity of body changes by equal amount, changes by equal amount in equal interval of time. What is there? In equal interval of time. If these things are there, then it is called as uniform acceleration. On contrary, if what is the meaning of variable or non-uniform acceleration? Means body undergoes unequal amount of velocity, in equal intervals of time. It is called as variable acceleration. So these are the two terms, uniform acceleration and variable acceleration. Now the point comes here, then what is the meaning of uniform motion? Actually the uniform motion is when a particle is said to be having a uniform motion when its acceleration is 0 and its velocity is constant. What is the meaning of uniform motion then? We have studied about uniform acceleration, uniform velocity. Now what is uniform motion? As I have said now, uniform motion means a particle is said to have a uniform motion when its acceleration is 0 and its velocity is constant. If these two terms are satisfying, then that type of motion is called as uniform motion. Now the next term is uniformly accelerated motion. Uniformly accelerated motion. Now when a particle moving with a constant acceleration, it is said to be a uniformly accelerated motion. Here what is happening? Acceleration value is constant. The term acceleration is constant. In the previous uniform motion term, acceleration was 0, but in uniformly accelerated motion, acceleration is constant. Next term is retardation or deceleration. The meaning of this is a very simple, means negative acceleration is called retardation. Okay, this. So when there is a negative acceleration, that means it is a retardation. So these are the few basic terms and definitions which is required to be discussed in this topic. Now considering the next article, that is rectilinear motion of a particle. Now rectilinear motion of a particle. When a particle or a body moves along a straight line path, then it is called as a linear or a rectilinear motion. We have discussed this already only. Okay, so many kinematics problems in linear motion can be solved just by knowing the concept of speed, velocity and acceleration. As I have already said you, in kinematics we are going to be involved with only speed, velocity. There is a difference between speed and velocity, we have discussed earlier, and acceleration. These three things only will be involved in kinematics, especially in the rectilinear motion of a particle. Now equation of rectilinear motion under uniform acceleration, we are going to derive this. So the term in rectilinear motion of a particle is equation of rectilinear motion under uniform acceleration. We have to discuss this topic as it is a very important topic. You are going to get so many formulas with the help of this topic. So to derive the formulas, consider a particle or a body which moves with a uniform acceleration. I have already said you what is the meaning of uniform acceleration. Uniform acceleration means velocity of a body changes by equal amount in equal interval of time. I have said you earlier this thing, what is the meaning of uniform acceleration. Now deriving the equation of rectilinear motion under the uniform acceleration. Now considering the particle, let this particle is having initial velocity which is to be denoted by u, this is initial velocity, then v be the final velocity. Okay, these velocities are in the unit of meter per second. Let A be the uniform acceleration. What is A? It is a uniform acceleration. Let me write here especially uniform acceleration. Okay. S be the distance. Let S be the distance in meter, and T is the time taken by a particle to travel in the seconds. Okay. So T is in seconds and this distance is in meter. So according to the definition of acceleration, it is a rate of change of velocity. We all know this thing. That's what is it is the rate of change of velocity with respect to time. Rate of change of velocity means how many velocities are there in our term in our equation. There is final velocity and initial velocity. So change in velocity means final velocity minus initial velocity with respect to time. Means we can write it like this: a into t is equal to v minus u. Like this we can write it. Okay. So from this we can also write it as a v is equal to, transferring this u in the left hand side, u plus at. So this is one formula we have derived in this equation of rectilinear motion under uniform acceleration. This is the condition, uniform acceleration. For uniform acceleration condition, for in case of rectilinear motion, v is equal to u plus at is our first formula. Okay. Now we know that the average velocity of a particle in time t is given by. Now what is the meaning of average velocity? Average velocity means the initial velocity plus final velocity, whatever it may be, dividing it by the number of velocities. Means we have two velocities here, u and v. So dividing it by 2, you will get the average velocity. Now this is the average velocity. Again, average velocity is the rate of change of displacement with respect to time. We also know this. What is the meaning of average velocity? Average velocity is rate of change of displacement, or rate of change of displacement with the time. Okay. So we can also write is a displacement by time, s divided by t. So equating these two terms, u plus v by 2 is equal to s by t. We can write this in terms of s, means transferring this t in this direction, in leftward direction, in leftward side actually, u plus v divided by 2 into t. This is s is equal to u plus v divided by 2. Now we know the value of v. What is v? This v is actually equal to u plus at. Okay. So this s will become equal to u plus, here v was there, so we are replacing this v by the u plus at. Okay. We have replaced the v by u plus at divided by 2 into t. Actually this t was with the dividation with s, so we have transferred it to the right hand side and it becomes in a multiplication relation. Okay. So now u plus u means 2u, so writing here 2u plus at into t. Okay. Whole divided by 2. Like this we can write. And one more thing we can do here, we can write in this way also, means multiplying this t with this term, you will get here ut plus again ut plus at square, multiplying this t with the numerator, whole divided by 2. So we can write this as a separately ut by 2 plus ut by 2. Okay. Plus at square by 2, just separating this denominator. Ut by 2 means half ut and half ut, it becomes 1 ut, so it will be written as a 1 ut plus at square by 2, or you can write here half at square also, or at square by 2, anything you can write here. So this is the second formula, s is equal to ut plus half at square, half at square. U is the initial velocity, a is the acceleration, t is the time. Okay. Don't forget this acceleration is a uniform acceleration. Now deriving the third formula, again we have one equation, that is v is equal to u plus at. This is our equation. Squaring this equation on the both the sides, squaring on both the sides, squaring on both sides. Okay. So v square is equal to u square plus, actually writing first it as u plus at whole bracket square. So using the formula a plus b bracket square is a square plus 2ab plus b square, using this formula u square plus 2at into u plus a square t square. This is what you will get after squaring it. Okay. So v square, you will get v square value, this is the v square, is equal to u square plus 2a taking common from these two terms. 2a is taking common, we are taking this as a common, we can write here 2a is outside it, so in bracket ut is remaining, plus a is already outside, so 1a is remaining, a we are writing here, t square we are writing as it is, 2 was not there but still we have taken it common, so we have to give it back, so 2 will be here, so ut plus half a t square you will get here. So writing this equation again, this v square is equal to u square will be there, plus 2a will also be there, ut plus half a t square, see here ut plus half a t square is equal to s, so we will write here s. So this is the new formula we have found here. So these three formulas, this is third number formula, this is second number formula, and the first number formula was also derived in the first page. Here v is equal to u plus at. So these three are the equation of motion in case of uniform acceleration. Okay, so we have to remember these three equations of motion under uniform acceleration. Now moving to the next article, that is distance travelled by the body in the nth second, under uniform acceleration, under uniform acceleration. Apart from those three equation of motion, there is one additional formula to find the distance travelled by body in the nth second. Actually this we have to derive with the help of those three equations only, so it is not a additional one along with those three equation of motion. This is not a fourth equation of motion, but it is the application of those three equation of motion. So in this case also, let u be the initial velocity, we have to consider it, okay, and v is the final velocity. The same thing we are considering here also. Actually we won't require this term final velocity in this case, but we have written here v with the final velocity. A is the uniform acceleration. What is the unit of acceleration? It is meter per second square. Okay, so distance traveled by the body in n seconds is given by, actually distance traveled by body, for it we have one formula, s is equal to ut plus half at square. This is the formula, but if we say that distance travel in n seconds, then you can replace this t with n, u into n plus half a into n square, like this you can write here. Again the distance traveled by the body in n minus 1 seconds. If someone asks you to calculate the distance travel in n minus 1 seconds, then we have to replace this t by n minus 1. S is equal to u into a is t, so n minus 1 we will write here, n minus 1 plus half a, here it is t, so we will write here n minus 1 square. Okay, so distance traveled by body in the nth second we can find now. Distance traveled by body in nth second. Okay, we have n seconds and we have n minus 1 second, so nth second can be found just by subtracting the n and nth second. Nth second, distance in nth second is equal to un plus half an square. This is what we have found earlier. Then subtracting this with the this one equation, s n minus 1. Okay, this is s n minus 1, so u of n minus 1 plus half of a into multiplying n minus 1 square and closing the bracket. Then after analyzing these terms, you will get one equation that is equal to u plus a by 2 2n minus 1. So distance travel in the nth second, you can use directly this formula to calculate. If asked about the distance travel in nth second, what is the distance that was travel in the nth second? So it is u initial velocity plus a by n 2n minus 1. This is the term we have to consider. Now next article in our kinematics of particles chapter is motion curves under uniform acceleration. Motion curves under uniform acceleration. Under uniform acceleration. Actually, what is the meaning of motion curves? It is a graphical representation. What it is? Motion curve means it is graphical representation. Graphical representation of what? Of, as we are studying kinematics only, this is our term we are studying here, kinematics. So kinematics is involving everything excepting only force. Okay, force, mass, weight, kg, whatever the terms of the force related, all those terms are exceptional in our kinematics study. So it is a graphical representation of what? Displacement. Okay, displacement or a distance, you can also say displacement, velocity, as we are always speaking about the direction, that's why we are writing here displacement rather than speed, we are writing here velocity, and acceleration. So graphical representation of displacement, velocity and acceleration with respect to obviously time, with respect to time is called as motion curves. Now first we will see displacement time diagram. Displacement time diagram. It is also called as ST curve. Why? Because displacement is denoted by S and time is denoted by T, so it will be called as a ST curve. And always remember that this time is an independent quantity, so it will be drawn on a horizontal or x axis this time, and all other parameters which are dependent or another parameter it is dependent on the time, then it will be drawn over the y axis. So ST will be drawn like this. Now displacement time diagram is drawn with displacement as ordinate, as I have said earlier here, and time as the abscissa. It is defined as a curve which gives a relationship between displacement and time. How will you define this displacement time diagram? It is the curve which gives the relationship between the displacement and time. Now to understand this ST curve, let us consider a body is moving under a uniform acceleration. Okay, then displacement time diagrams are drawn. Suppose the curve is horizontal, displacement becomes constant. This displacement is constant. If this is constant, what does it means? The curve is a horizontal. This curve is horizontal means displacement is constant. Okay, so the slope of graph is 0. The slope of this graph is 0. Okay, it means that the body has no velocity and is at rest. Displacement is constant means it is not moving, displacement is not moving. Okay, it is not increasing means the body is at rest and there is no existence of velocity. Now suppose the figure is like this. This is the figure. It means that the displacement is increasing linearly with the time. So the slope of the curve remains constant. This slope is constant. Okay, here the slope was 0, here the slope is constant, hence body is moving with a uniform velocity. Now if suppose the curve is like this, the curve is like this, what does it mean? The displacement is not changing by equal in magnitude in the equal interval of time. So the slope of the graph becomes different at different time, hence velocity of the body changes with the time. What does it represents? It shows that velocity of body changes with time. So these are the three ST curves we have to take into consideration. Now what we can comment on this type of curves which is drawn for displacement time diagram means when the slope of ST curve is 0, means this case when the slope of this ST curve is 0, then body remains at the rest and velocity of the body is 0. But when ST curves vary linearly, means the slope is constant here, it gives the uniform velocity of the body. It gives uniform velocity of the body, which is given by v is equal to ds by dt. This is the uniform velocity of the body. But when the st curves varies non-linearly, then slope st curves gives the velocity of body at a particular interval of time. For a particular interval of time, suppose at this interval of time, the velocity will be ds by dt at this instant only. Okay, so for non-linear variation, what we will get? We will get a velocity of a body at a particular interval of time. Now we will, after discussing displacement time diagram, we are going to study about the velocity time diagram. Now what is the meaning of velocity time diagram? Let me show you. Velocity is O, is velocity. Okay, velocity time diagram. In short, we can also say it as a VT curves or VT diagrams. Okay, so in VT curves, actually a curve which shows the relationship between the velocity and time of a body under uniform acceleration, that is linear uniform acceleration, it is called as velocity time diagram. Such diagram shall be drawn with velocity along the y-axis and time along the x-axis. Why? Because time is an independent parameter, we have to draw it over the x-axis only, and velocity will be here. Okay, so actually we have 4 diagrams here, so we will draw like this. This is the time, okay, and this is the velocity. Suppose the first graph is like this. Okay, so the velocity of body increases linearly. What we are observing here, velocity is on the y-axis and time is here, means velocity is increasing linearly like this. Okay, with respect to this time. So it indicates that a body starts its motion from the rest position. That is, initial velocity of the body is 0. Then the slope of curve is uniform, so an acceleration of a body remains same. The slope is constant, slope of the curve is uniform. It means that the acceleration of a body remains same. Thus body moving with uniform or a constant acceleration having initial velocity 0. What does it represent? It represents that the slope of a curve is uniform. Okay, slope of curve is uniform means acceleration of body remains same. Now for the second figure, suppose in this figure this starts from this line, means initial velocity is something present here. What does this curve represent? The velocity of body increases linearly with the time with some initial velocity. Okay, the body is starting with some finite initial velocity. The slope of curve is constant, so an acceleration of a body remains constant. Here also acceleration of a body remains constant. So in these two curves, what we are getting that the acceleration is constant. The difference in these two curves is only that here the initial velocity was 0 and here initial velocity was having some initial value, some finite initial value. Okay, so for third curve, suppose this is the curve like this, it is linearly decreasing from certain point to the 0 value of the velocity. So the body moves with some initial velocity, and as the time passes, means as this time passes, what happens? A velocity of body decreases linearly until its final velocity becomes 0 and the body comes to the rest. So this body has a same or uniform retardation. Here same retardation is there, same retardation is there. Here same acceleration was there, here same acceleration was there. Okay, so now for the fourth figure, what is fourth figure? Fourth figure is somewhat like this. We know that the velocity is here and time is there like this. So velocity time diagram or a curve varies non-linearly, therefore the slope becomes different at different times. Hence velocity is not changing at constant rate. So the body does not have uniform acceleration. Non-uniform acceleration is present here. Non-uniform acceleration. Okay, so we have concluded about these 4 curves here. Okay, so after this linear motion under gravity, this term we have to discuss. Now what is the meaning of linear motion under gravity? This is the new term actually. The new term is, we have to study here, linear motion under gravity. We know that every body experiences a force of attraction towards the center of the earth, which is known as a gravity. Okay, so when a body is allowed to fall freely, it is acted upon by an acceleration due to gravity, and its velocity goes on increasing until it reaches to the ground. Next thing is that as we know that the force of attraction of the earth pulls all bodies towards the center of earth with uniform acceleration, and it is known as a acceleration due to gravity. The value of acceleration due to gravity is constant. In general, it is taken to be 9.81. It is denoted by g, so it is equal to 9.81. The unit is meter per second square and is always directed towards the center of the earth. Acceleration due to gravity is generally denoted by g. Okay, so these terms we have to remember. So when the body is moving vertically downward, this is a sign convention actually what I am going to say now. When the body is moving vertically downward, means like this, downward direction is there, the value of g is considered to be positive. But if the body is thrown upward or it is moving upward, means opposite to the direction of gravity, then g is taken to be negative. This is the sign convention we have to consider in while calculating or while analyzing the problems. Okay, so then acceleration due to gravity is taken as negative here. It is if it is upward. So evidently all the equations of motion are applicable except by replacing uniform acceleration with acceleration due to gravity, and these are written as, actually we have seen the equation of motion as v is equal to u plus at, then the second term was s is equal to ut plus half at square, and the third term was v square is equal to u square plus 2g s I have said. Okay, 2gh or s you can write here. But when the body is projected vertically upward, what will happen here? When the body is projected vertically upward, then v is equal to u, that is here u is written u minus gt. Okay, a is replaced with the g and it is upward for upward motion, means which is opposite to the gravity, it will written as minus g. Second is s is equal to ut minus half gt square. Okay, and the third one is v square is equal to u square minus 2g s, or you can say here h also. S is equal to h in case of the vertical or downward motion, because what we say that the particle has covered height h, so s is replaced by h. In horizontal motion, what we say, this is the h distance. In vertical motion, we say that this is the h height. Okay, so replacing this s by h can take place. Okay, so no problem in this type of questions. So problems will be covered in a live lecture.